This module focuses upon estimation and scheduling basics. Most of us have had some training in statistics. Frequently, our training in statistics ended with mutual ill will between ourselves and the topic. This presentation is going to focus on how use of some statistical tools and a spreadsheet will allow us to have much better control of our work in our project. We have highly skilled knowledge workers that have never been trained in estimation techniques, so their estimates tend to be flawed. If we are building schedules based upon flawed estimates, then the schedules are by definition flawed. If the project team does not trust the estimates and tries to schedule without reliable estimates, then the schedule is once again flawed, but for a different reason. Years ago, I listened to a sports coach who had developed Olympic athletes as well as some of the best professional athletes in the world. When he was asked how to develop a team of athletes at that level, he emphasized focusing on basics. He then clarified that focusing on the basics was simple to do, but it was not easy to do. This applies to estimation and scheduling. It is critical that the project team remember that the schedule is really to allocate resources. We tend to focus upon dates when really the dates are an outcome of allocating the right resources to the work at the right time. Scheduling must be an ongoing activity throughout the project. The schedule should be being revised based upon people's actual performance. Both our schedule and our estimates need to be discussed openly. The team cannot operate effectively if the team members do not understand how the schedule was arrived at. Finally, our estimates and our schedule are much stronger when we apply statistical tools. The typical organization applies statistical analysis to its operations routinely. This should apply to its projects as well. This slide is a mini course in statistics. Most of the original work in statistics was done by gamblers, so I will use dice as an example. The table below shows the values that you can get when you roll a pair of dice. The next row of the table shows the frequency for each value. For example, there is only one way to get the value 2 from a pair of dice. The next row shows the percentage of the time the values should occur. For example, the value 7 will occur 17% of the time. If you're placing a bet that 7 will occur when you roll the dice next, you are betting on the most likely occurrence. However, 83% of the time you will lose. Let's change the bet to betting that the value will be 7 or less. Then you will win 58% of the time. The graphic below the table shows what is referred to as a bell-shaped curve, or a normal distribution. If you've had any lectures focused upon Six Sigma, you've been exposed to this graphic. At the bottom of the graphic, you will see several Greek letters that translate to the average and the standard deviation, or sigma. I will end the statistic lessons at this point, and we will apply it in the next slide. More than 50 years ago, a thorough analysis of knowledge work was done. It showed knowledge work typically to be a skewed bell, as shown in the first graphic. Analysis of the work shows a best case or optimistic duration, followed closely by a most likely duration, followed significantly later by a worst case or pessimistic duration. The analysis showed that the most likely duration was less than the average duration. If you wanted to know the average duration of the task, you would apply the formula optimistic plus 4 times the most likely plus the pessimistic, all divided by 6. They labeled this the expected duration. This was a critical insight since so many of our knowledge workers would use the most likely duration as their estimate and be wrong 70% of the time. The analysts wanted to apply basic statistics to this and determine the standard deviation of the work. This is more complex. First, you must determine what is called the variance. The formula is shown on this slide, and I recommend that you set up a spreadsheet to work this out for you. Once you have the variance, you can determine its square root, and that is the standard deviation. Once again, this is a standard function in a spreadsheet. Now you have far more knowledge about the work, as you can see in the graphic below. I can identify the duration that we should finish on or before approximately 50% of the time. Similarly, I can determine durations with a probability of 84% or 97%. The formulas for this exercise are not that complex, and it is relatively simple to build a spreadsheet that will generate the data. Once we have it, our estimates have just become substantially more understandable and manageable. If a project team has only one schedule, then the project is not being managed well. The project manager should always be working on multiple schedules based upon current performance and trends. The project team should maintain several schedules, the first of which is the project plan of record. This schedule in the plan of record is the official schedule shared with all the stakeholders. At the beginning of the project manager should have established the sponsor's risk tolerance. That risk tolerance should be being used in developing our schedule. If the sponsor wants the probability of schedule success to be no less than 70%, i.e. he or she is willing to accept a 30% risk, we should be using durations that align with that risk tolerance. The team should have an internal schedule based upon the expected durations determined from our estimates. This allows the project manager and the team members to focus upon hitting their most likely estimate, but recognizing that as happening less than 50% of the time. This allows the team to recognize trend very early. 50% of their activities should be finishing on or before the expected duration, so the project will be hurt less when the inevitable happens. The fully resourced schedule reflects what resources the project would need if it was going to be given top priority. When things go wrong in a project, it is not unusual for senior management to turn to the project manager and ask, quote, "What do you need?" unquote. As the project manager, you want to be ready to answer that question instantly. Every project manager wants to understand and control their schedule well. A schedule that is based upon good estimates is fundamentally easy to understand. If I understand it better, then I can control it more easily. The table on this slide shows a reasonably easy control tool that can be used if the estimates were developed using the three-point technique shown on a prior slide. All it requires is rows, columns, and check marks. The first column shows the identifier of the activities and tasks. As a task is completed, an X is put in the appropriate column. If the task finishes at or before the duration identified as most likely, then the X goes into the column labeled capital ML. If the task duration exceeds the most likely, but is less than or equal to the expected, then the X goes into the second column. If the task duration exceeds the expected, then the X goes into the column labeled high. About 1/3 of the X's should be in the column labeled ML. 50% of the X's should be in the two columns labeled ML and less than or equal to expected. If either of these is not the case, the project manager should be reviewing the estimates and people's investment of time. You will note that this chart would be an easy graphic for the team to understand. As said earlier, controlling the schedule is simple when it is based upon good data. In conclusion, we can recognize a number of points. Our schedules should be based upon well-developed estimates. If our estimates are flawed, our schedules will be inaccurate. If our estimates are rigorous, then the schedule will be of much higher quality. It is critical that the project manager and the project team invest the time in understanding good estimation practices and spend the time to develop good estimates. Without this investment up front, the project team will invest far more time later in the project addressing schedule issues. As I have emphasized repeatedly in this module, statistics really do work. The project manager using these statistical formulas will have far more control of their project. The project manager should invest the time to build a simple set of spreadsheets that apply these formulas. They will be useful in multiple projects. The simple table showing the completion categories of most likely, expected, and high for the various activities in the project is a wonderful graphic for the project manager to have posted where the team members can see it. It gives a quick visual indicator of how well the team is doing relative to their original estimates.
Thank you for participating in this video vignette. We hope it has been helpful and insightful for you. We have included some further reading and research to help enhance your learning experience.